name is Laura Holmes. I'm a sophomore at the Rockdale Magnet School for Science and Technology. The title of my research project is The Force Exertion Variations of Athletic Playing Surfaces. The use of artificial athletic turf has been on the rise as of late because unlike natural turf varieties, it is not confined by climatic conditions, nor does it require extensive and costly maintenance. Simultaneously, there has been an increase in the incidence of athletic injury rates. Based on previous research from other sources, the rising use of athletic turf fields may be a contributing factor to more injuries, as athletic turf is stiffer and has a greater projected force exertion than its natural counterpart. The experimentation involved in the research will be testing the amount of force that has been exerted between the playing surface and the sole of a weighted shoe. The increased force exertion between the shoe and the field sample interface correlates to a greater frictional coefficient of the surfaces. Kinetic friction is related to the force that is exerted between surfaces before one is overcome into motion. It is proposed that the higher force and frictional characteristics may contribute to the athletic injuries in the lower extremity, twists, bone breaks, and tears of muscles and ligaments. Knowing the force exertion values and tendencies of athletic playing surfaces would better enable sporting goods companies to design and manufacture equipment more suited to fit the characteristics of the surfaces. By determining the force exertion characteristics of natural grass and artificial turf, future research may be conducted to determine their effects on the human body. The purpose of experimentation was to determine the variation of force exertion between natural grass and artificial turf as differing environmental conditions were applied. It was hypothesized that the artificial turf sample would exert a significantly greater amount of force when a weight was pulled across it. When the environmental conditions were applied, it was hypothesized that the wet conditions, rain and sleet, would exert the lowest force quantities. An accelerometer was placed on the shoe to help ensure a constant flow during each trial. The collected data was analyzed in the Minitab program. The highest point of force for exertion was observed for each trial. This point correlates to the static friction coefficient of the surface. The average of all the data points following the maximum value represent the kinetic friction coefficient as the object was in motion during this time. An ANOVA analysis of variance test was conducted comparing the two surfaces and the applied environmental conditions. The results were determined to be significant. As a majority, the Bermuda grass surface exerted a higher force value. This is contrary to the hypothesis. These results may be contributed to surface characteristics, such as the grass blades and infill. The blades of the Bermuda grass were sporadically distributed, while field turf was much more uniform. Field turf blades, the artificial turf surface, became less stiff when heat was applied. The artificial turf contained a rubber and plastic pellet infill, which may have affected the force exertion of the material. As of now, it is difficult to determine which surface is safer for athletic play. Future research testing the effective force on lower extremity injury is desired to be done to make a solid statement as to which surface, artificial or natural turf, is the safest for athletes.